Okay, so just listen carefully because I know I did talk about it on Friday, but obviously a weekend happened, right? And we forget sometimes. When you think of odds, think of two dots. Odds, two dots, right? Like that's number one. And that's what I mean with it, right? It's always going to have two dots and then numbers on either side. I will never write odds as fractions. I know that you may have learned to write it as a fraction. I don't do that because it confuses students, right? As a fraction, probability is a fraction. What's up with that? I'm not going to do that. What I need you to remember, please remember this. When you have odds and you're asked to find the probability, you're going to have to add the two numbers and put them in your denominator. That's going to give you the total number of outcomes. Okay? Lolo? What else did I want to say? It always compares it happening to something not happening. Okay? So you got it. There's no total ever. Okay? You can't say, listen carefully, if I ever give an odd like this and I ask you, what does that mean? Oh, it means that 8 out of 2 times you're going to win the game. It doesn't even make sense, right? 8 out of 2 times, it doesn't make sense. But even, don't write this down, but sometimes it could actually be, I could give you, hey, what does that mean? Oh, that 2 out of 8 times this team is going to win. This is saying that it's going to win 2 times and lose 8 times. So that means that 2 out of 10 times this team is going to win. 8 out of 10 times this team is going to lose, right? So watch out with odds. I'm going to erase this. Don't write this down because you're going to wonder why it's there. Let's keep going. So I'm going to just walk you through this. I have the wrong booklet in front of me, I think. I do have the wrong one, but I think I did this with you already. So let's go to page 17. You're going to help me out here because I forgot myself. Is 17 filled out for you if you were here on Friday? Thank you, because I'm not always sure exactly because I have a draft and a clean and I think I mixed them up. So this should be fine then. Did we do 18 as well? Page 18? Yeah? If you were awake and you were here, you should have this filled in. I'm pretty sure too. Like, I'm just trying to confirm, okay? Okay. Then that means that 19 and 20 is not filled in yet, right? No. Okay, good, good. We are on the same page, literally, right now. I would like you to try 19 and 20, but before we do that, I know it's going to be a lot of back and forth, but I just want to review real quick. If you don't mind me doing that, I'm going to go to 17 and just use this to help you refresh your memory a little bit. And then 19 and 20, you're going to do a little bit of work, and then I'm going to review it. We're going to move on to some other stuff. We had odds and probability kind of side by side. It's not always going to be the case. But how did we do things, right? So what did we look for? Well, first of all, here we had odds, and it said odds of something happening. That is the same thing as in favor. Write that down. In favor. If something says odds of, it's actually saying the same thing as, hey, what are the odds in favor of this happening? You got that, right? So they're the same thing. This could say against, though. This word of can be substituted later on with against, which means our numbers are going to be in a different order. You're with me, right? So if it says in favor of what? What? Winning, green, whatever. That event comes first, and you do not want that event on the right side. So it's closest to you, because you always read from left to right. So if it says of, then the event you want is closest to you. However, let's go find against. Dun, dun, dun. Question E on page 17. It says here, odds against what? Odds against what? Well, let's keep reading. Odds against getting a yellow one. Watch where yellow is. Like if you focus on the event, yellow is on the other side of the fence. It kind of considers a fence. So yellow is there now, which means not yellow is going to be up front. When it's stated like that, odds against, put the event on the other side and then not goes in front. That's the key here. You got to remember, basically focus on the event and then the other one will be not it. Okay. So if I were to fill this in, I would go, okay, odds against yellow, I'm going to put yellow here. Therefore, this is not yellow. And I start with this. I mean, how many yellow sections does that spinner have? How many are not yellow? I take the total and I subtract what I have already from it. So that means 7 are not yellow. 1 section is yellow, right? So that's what this is saying. And then we went probability of not getting a yellow one. We went 7 plus 1, right? We added these two up to give us our denominator. And the top, we grabbed a 7, right? We grabbed this number because that's what we're after. Like how many times would you not get a yellow? Well, it's 7 out of 8 times, right? And so watch out for that. So the bottom, this gives you your total, right? And so that's very important to do that, to get that right. I talked about reducing ratios. Ratios, that's what odds are written as. That's a format. We call these are all ratios here. But we can divide both of them by 2 and then get our 1 to 3, right? Both of these, either one of these, you could have used to come up with the probability. It doesn't matter. They're both right. Okay. So I want you to, with this review, work on pages 19 and 20. Okay. It's the same thing as this spinner. It's just there's no spinner in this case. There's donut. It could be whatever, right? So go to page 19 and 20. Read carefully. Is it asking for a probability or is it asking for odds? I'm going back and forth here. Okay. And then you try 20 as well. And you go for it. Take a few minutes. All right. I'm going to start going over this. So remember, anytime you see some weird statement, what if somebody randomly picks one? And it has to be for this to be accurate. If you look, right? If you look before you're grabbing, then it's not random, right? And this is like the probability is not accurate, right? So first of all, you should probably the first thing you should recognize that there are 20. The total is 20, right? 20 outcomes, 20 options. So this is like a spinner with lots of sections. We have like 20 sections in it, right? State the probability somebody randomly picking honey dip, right? So probability, that'd be 20, and we know that there's 4 of them. If I ask you to reduce this, you should recognize, hey, I can divide them both by 4. You get 1 over 5, right? State the odds. Odds against are 4, right? And it's in favor. Odds in favor of what? A chocolate dip donut. So you want chocolate, and the other side would be not chocolate. That's basically what's happening, right? So you just go grab your chocolate dips, right? And on the other side, I will do total minus chocolate, right? So that means that 5 are, 15 are not. That would be okay. You can divide both of them by 5. So that'd be 1 to 3. So you're saying that on a smaller scale, out of 4 donuts, 1 will be a Boston cream, 3 will not be a Boston. Sorry, chocolate dip. State the odds against, circle that word, right? Against what? Somebody picking a Boston cream donut. Because of the wording, you're going to put Boston here, right? And this will be Boston. Watch, I'm going to do the, remember the bar, right? Some of you are thinking of a different bar. No, stay here, probability, right? That means not, right? So you first start with Boston cream. So you go up there. We have 8 of them. And on this side, we got 12 minus 8. So it's 12 to 8. You can divide both of them by 4. And so that gives us 3 to 2, right? I don't ask you to reduce a whole lot, but these are easy enough numbers to be able to, for us to be able to do that. State the probability against someone picking an apple fritter. It's like saying not apple fritter. So probability against apple fritter. Let's make sure we have a 20 there. And we don't want apple fritter, so it'd be 20 minus, we've got 3 of them, right? So that means it's 17 over 20. Okay, 17 over 20 is the probability there. I had more space, I could have added more. Okay, let's keep going. Maybe I should tell you what's happening down the road. I could now say if you had 8 dozen donuts, right? 96 donuts. And you had the same spread, right? How many would you expect to be Boston cream, let's say, right? How many would you expect Boston cream? That's a prediction, right? You figure out the probability of Boston cream in this scenario, multiply it by 96 donuts, right? And you kind of predict. So that's all still happening, okay? Let's go to page 20 here. Highlighter. The odds against Mr. D giving an AC on any given day is 2 to 3. Because it says against AC, I'm going to also highlight AC. Against getting an AC, so that means that this will be your ACs, right? This number represents ACs, and this number, can you see that? I think it's good, right? This would be not getting an AC. Because it's worded odds against AC, then you put the ACs on the right side. A student sees this and, supposed to say and, sorry, typo, and claims that it is unlikely that Mr. D gives out an AC. Is this claim correct? Right? We'll make a point here. State the probability that an AC will be given on any given day. Okay, so probability of getting an AC would therefore be the first number you will write down. You're going from odds to probability is 2 plus 3. Okay, 2 plus 3. And because the 3 represents my ACs, I put the 3 on top. So this would be 3 over 5, which would be 0.6, which would be 60% chance. Quite often when you're comparing and trying to make a point, I would turn it into a percentage. This is the number I would focus on, right? And then we're going to justify whether or not student's claim is correct. What do you think? If it's 60% chance of rain, there's a higher likelihood of rain than not rain, correct? So if it's over 50%, it's more likely for it to happen than for it not to happen. Okay, so we'll answer it that way. I'm going to go by my script here. Okay, the students claim is incorrect. Comma, since the probability of Mr. D giving an AC is greater than 50%. Okay, it's greater than 50%, and here's my visual here. You have a spectrum from 0% to 100%. Impossible to certain, right? And in the middle, you have your 50. That's why the Weather Network or whatever app will never say it's 50% chance of rain today, because then you might as well just toss a coin and figure it out for yourself, right? If it's 50-50. So they will usually go 60, 70, 80, or on the low side, they'll go 40, 30, 20, right? So 60% is somewhere in here. Okay. This is likely. This is not likely. If you're anywhere under the 50% mark, we would consider it not likely. If it's over 50%, then there's a greater chance of it happening than it not happening. I hope that makes sense. So when you have odds, you want to turn them into a probability to work with them, right? If you have two different odds, you're like, which event is more likely to happen? Turn it into a probability, turn it into a percentage. That's the best way to go about it. All right. Next. I feel like I did this already. Maybe I was dreaming about it. I did a different word, right? Yeah. Okay. Consider the word trigonometry. First thing I'm going to do is count. 2, 4, 6, 8, 10, 12. Total would be 12 letters. Okay. And so what's the probability of drawing a T? We're in the probability, right? Probability of a T. And I go count, there are 2 T's out of 12. We can reduce that, right? No problem. Boom, we're done. The odds of drawing a T, so that means T compared to not T. Okay, so how many T's? We know that there's 2, therefore not grabbing a T is 12 minus 2, so that's 2 to 10. 2 to 10. Remember, there should be no 12 when it comes to odds, right? What's the probability of drawing a vowel? Probability of a vowel. We know that we're back to probability, so there's 12 letters. A, E, I, O, U, those are vowels. So let's go count. I, right? 1, 2, 3, 4. Y is not a vowel, right? 4 out of 12 would be the probability of grabbing a vowel. The odds of what? Consonant. Consonant is whatever is not a vowel is a consonant, okay? So that means odds of this happening, consonant versus not it. I could have just done C, not C, right? Make it a bit easier. So what are you going to focus on? You know what I would focus on now? Not like I would focus on the answer that I just had here. If 4 are vowels, that means that the rest are not. So there are 8 consonants, and then it's 12 minus 8, so that'd be 8 to 4. That would be the odds of. So you just go count how many consonants do I have? 8. Therefore, I have 4 that are vowels or not consonants. So, like, why is English showing up here, right? Like, leave me alone. We're good? Let's keep going. No. Okay. You're gonna be okay. Right now we're going the other way. I'm telling you, way at the top, you're converting probability to odds. Okay? You're going from probability to odds. Just like we can convert odds to probability, we can also convert probability to odds. So watch this. I'm going to add to this chart. I would have us somewhere on my study sheet both, right? An example of both. So if you had probability, these are the outcomes of A happening, right? And then total is at the bottom. Watch what happens here. If you want odds in favor of A, so like this event, right? We put that event up first, and on the other side, we go total minus 8. This is, let's put this underneath here. This is basically saying not A. Got it? It's basically, that's how we find not A. We just go total minus A. Okay? On the other hand, if you want odds against A, then watch. A is on the other side, just like we've discussed. And then we go here, and this is not A. And when we're done with this, I'm going to try to come up with a clever way of just summarizing it. Just let me think a little bit, a day or two, and I'll maybe have a summarized version of this. Maybe I might even add that to this section here, but not right now. I have to think it through. Okay, let's keep going. So let's use what we've just discussed here to answer the following. The probability of a plane crashing is estimated to be 1 in 11 million flights. 1 in 11 million. It says here, state the odds of, so odds in favor of a plane crashing. So crash, and on the other side, it would be not crashing. Right? So we're told that the probability of it crashing is 1. So you put 1 here. Give yourselves room because it's a big number. 1. Can I just go up here real quick? The 11 million. Let's just make a note that this represents total of, right? Total. And this is sort of the 1 represents A, right? That event. In this case, it's the plane crashing. So 1, and we have 11 million on the other side. 1, 2, 3. 1, 2, 3. And what are we going to do there? Minus 1. So it's kind of very important to get this exactly right. 1, 2. So you grab your calculator, or you just answer because you might just know. This is 10,999,000, right? 11 million. There we go. 10,999,999. So there's 1 plane crashing for every 10,999,999 that are not crashing. It's good news, right? It'd be better if it's a bigger number on the right side, right? The bigger the number on the right side, the less likely it is happening, right? State the odds against plane crashing. Odds against. This is very important here. Odds against. That means that crash goes here, that event that it's against, not crashing goes on the left side. So we're basically just going to take the previous one and flip it, right? We're going to flip it. So you go 10 million, followed by 6 nines, and there's the 1 on the other side. So that would be the odds against a plane crash. Okay, a couple more. State the probability of a student passing the probability unit test. Sorry, the probability of a student passing the probability unit test, tongue twister, is 95%. Let's write that as a fraction. Much better, much better. 95 over 100. State the odds of a student passing, right? We're just going to go equals 95 over 100. Odds of in favor of passing. That means that we'll focus on passing and then not passing. So pass would be 95, right? And then you go total minus 95. So you have 95 to 5. You can divide it by 5, right? It's 19 to 1. Odds in favor of passing would be 19 to 1 or 95 to 5. It's up to you. State the probability. Read carefully. What is it asking for? Probability against a student passing. So probability of not passing. I think you can just say that it's 5 over 100, right? Or 5%. Passing, not passing, they add up to 100%. Read C and try to answer that one. Just take a minute. State the odds of a student not passing the unit test. Is there a way to rewriting it or rephrasing it in your mind even? Can you say it in a different way so you know exactly how to answer it? It's actually not. You have everything you need in front of you. You need to know what to do when I ask you this kind of question. You can also write it like this. Give me the odds against passing. That means that passing is here, and this is not passing. So I'm just going to say go up here. Not passing, according to this formula up here, not passing is on the right side. So that number comes first. And then 19 comes next. Flip A, right? I'm just flip-flopping A. Okay. Let's continue. I'm going to make a prediction here using that, and then I'm going to leave you on, you're going to do some on your own, okay? Come with me. One more. And then you got to promise me you're going to try, right? You're not going to just sit there. Page 22. One more question. That's it. The odds against a smart TV being defective from factory are 20,000 to 3. Oh my goodness, my head is hurting, right? You might say. So odds against what? TV being defective. So we're just going to call that defective. Against defective. So if you go against being defective, then this means that it's defective. And this means it's not defective. The odds against a TV being broken, you want to call it that? Sure. Against a TV being broken. So against being broken, so if it's against you, then broken is on the other side of the fence. And just think about it, like no company would work if these numbers were opposite, right? So 20,000 TVs are good, they're not defective. 3 are broken, right? So that's kind of what's happening here. So try to sometimes just wrap your head around the situation. You can say good, bad, right? Same thing, good, bad, okay? If a company produces 64,000 TVs per month, how many would be defective in a year? How many of those TVs would get like a 1-star rating on Amazon because they're like broken right out of the box? Okay. So watch what I'm going to do here. Just follow along, okay? Follow along, guys. You're making a prediction. So I'm going to focus on the month and then the year, okay? I'm just going to focus on a month here. So let's say prediction. Prediction would be probability of defective, right? And I'll multiply that by larger sample. That's what I'm going to do there. This is just for the month. Right? Go ahead. So probability of defective, I would say if I wanted to come up with the probability of something being defective, I'm going to add these two numbers because I remember odds to probability. I want that to be out of 20,003. And I'm going to grab the 3, right? Because I'm interested in the probability of a TV being broken, right? So I'm going to take that and I'm going to multiply that by 64,000. Let's do the math there. 3 divided by 20,003 times 64,000. Watch this. 9.5985 ... right? broken TVs per month. You're like, why aren't you rounding, Mr. Dirksen? You should be rounding right about now. Not yet, because they're asking me for a year. Got it? So you're not answering yet. You're just in the process. So we're gonna go times. So there's about 10 TVs that are not working every month, right? Times 12 months. Let's multiply this by 12, and now we're gonna round. That's 115.182 and so forth, which is approximately 115 or 116 broken TVs per year. Wow, right? It's a lot of broken TVs, if you ask me. And so here we go, right? Like, what happened here? There's so much going on. We turned our odds into a probability that we could use to make a prediction as to how many are broken per month, and then times 12 to figure out how many are broken in a whole year. So it's almost like you should have recognized the prediction part. It's the how did I come up with the probability that is somewhat new, right? But not really. You'll be fine. Okay. I wish I could. I would have gone 20,000 plus 3. I don't know if you feel like you need to add that. 20,000 plus 3, right? This is the total. That's how I came up with that. And I think I used green and orange the other day. And it doesn't matter. Right? Just to see, oh, okay, that's how that happened. And I came up with that numerator going back to the odds there. So I have a bunch of probabilities like coming up. I got them off the internet, so I don't know how accurate they are, but I think they're pretty close. Obviously, will vary. So use what I've taught you, use what you know, and work through pages 22. Right? You do 22. All the way to 25, I would say. I don't expect you to do it all today, but maybe 22 to 23 at least. At the very least, give it a try. Okay. Thank you guys.